Number 35, two vectors R and S lies in the xy plane. Their magnitudes are 4.5 and 7.3 units respectively, and their directions are 320 degrees and 85 degrees respectively as measured counterclockwise from the positive x-axis. What are the values of the dot product RS and the cross product RS? So first we have to write vector r and vector s as in unit vector notation. So we have to find their components. The x component of vector r can be calculated by the absolute value of vector r times the cosine of the angle, which is 320 degrees. Remember that this value over here is 4.5, and this gives us 3.45 roughly. The y component of the vector is the magnitude of the vector, or the absolute value, times the sine of 320, and this gives us minus 2.89. So vector r in unit vector notation is equal to 3.45 in the I direction minus 2.89 in the j direction. So this is vector r. The x component of vector s is equal to the absolute value of the vector times the cosine of the angle, which is 85 degrees, and this gives us 0.64. The y component is equal to the absolute value times the sine of 85 degrees, and this gives us 7.27. So vector s is equal to 0.64 in the I direction plus 7.27 in the j direction. Okay, so we are ready to go. So letter A, we want to do r dot s. So we just have to multiply their components. So let's paint this red and this blue. So the dot product would be 3.45 multiplied by 0.64 plus minus 2.89 multiplied by 7.27, and this gives us the result, which is minus 18.8. So this is the answer of letter A. For letter B, we have to do the cross product. So for letter B, it is the cross product, and the cross product is the determinant of this matrix over here. So the first row is always the same, is I hat, j hat, k hat. The second row is equal to 3.45 minus 2.89. So this is just vector r and 0 in the k direction. Vector s is 0.64 and 7.27, and this is 0. So you just have to do the determinant of this matrix, and then you would find 26.9 in the k direction. And this is it. That's it. That's the answer of letter B.